Okay, everybody, I'm going to do a video lesson on trigonometry for you. I find this as a topic is probably a better thing to do on a video. That way you can pause and rewind as you need to as you go through, because you'll find that people pick it up at different rates and different levels. So some will be able to rattle straight through, some will need to just go back and double check the steps. No shame in either. We're not worried about that. It's just what we can pick up as we go through. Okay, so we can see our beginnings there. We've got our SOHCAHTOA set up in our triangles, our calculator. And strangely enough, we're not going to be using that too much during this session, only for the final steps. Okay, so I'm going to move that to one side and bring our pad a bit more central. And I'm going to be working partly from a PowerPoint, which will then be shared with you, but also each of the questions as we go through here, and also the examples. What we will also then see is that, well, basically I'll go through them on the paper rather than on the PowerPoint, because we can then see how we would write the steps down, and it's I find it easier to do it that way as well. Okay, so we'll have a look. We've got our learning objectives first of all. So basically, let's see, kind of proves what we're saying, really. We're going to identify methods for finding missing sides in right angled triangles using trigonometry, and also then practice calculations to find not only missing sides, but angles as well. Okay. So our trigonometry, as far as we're concerned, we're dealing with foundation level, and we only deal with right angled triangles. So don't worry about any other types at the moment. If those of you who are doing higher, well, you should know this lot by now, I'll be honest. But obviously there will be other videos available then to take you further on with the non-right angle stuff. Foundation level, we don't need to worry about that. Okay, so trigonometry. Three things we need to worry about first off. And it's what we call the sides. And the longest side, so that's this side here. So it's the longest side opposite the right angle is always called the hypotenuse. And we can identify just with the letter H. At times you will hear me refer to theta, and it's just the Greek letter theta, and it's just I'll use that to represent an angle that we don't know. Okay, so if you hear theta, it's just represent an angle that we don't know at the moment. It's not something you need to remember. It's not something you need in an exam. Okay, it's just to help us. Basically, it's going to be a placeholder for us during this process, so we're not constantly talking about an unknown thing. Okay. We've then got the opposite side, and that, as it says, is located opposite the included angle. Now, when we talk about the included angle, that is the angle that's given in the right angle triangle. Once, similar when we dealt with Pythagoras, once we know it's a right angle triangle, we can ignore that little square that tells us a right angle. We no longer need it. We don't need it as part of any of our calculations. Okay. So when you talk about the included angle, it is to do with the angle that's given there on our corner. And then we've got our adjacent angle. And adjacent means next to, okay? So they're saying it's located between the right angle and the included angle. We also know that it's the side that's next to the angle that we're given, okay? So they're the first three, and that forms the first part of this process for any of the trigonometry questions that we do. Okay, so for trig, like we say, we talked about this with the learning objectives, didn't we? Going to use this to find missing angles in the lengths of triangles, and we're going to use three functions. We've got sine, cosine, and tangent. And it says we will start working with right angle triangles. Don't worry, that is all we are working with. If you want to go further than that, that's up to you. So, important words. The first step. It's the most basic and it's the most important. And we've got to label the sides, because if we don't get these labels right on the triangle, it's going to set us off down the wrong path. So as always, in this case, here's our Greek letter theta, as we've mentioned before, and that just tells me that's where my angle is. We know this longest side is going to be the hypotenuse. It always is, okay? And we know that because it's the longest side of the triangle and it's opposite the right angle. So then that means now the opposite is opposite the angle that we're given, so opposite theta, and the adjacent is next to the angle that we're given. So in this case, it's next to theta, okay? Now, if that angle was up there, then these two sides would not be correct as they are, okay? They would actually switch around. So now we can see, again, we've got our included angle, theta is at the top. So that means this bottom side is now the opposite. It's on the far side of the triangle from where the angle that we're given, and the adjacent is still next to the angle that we're given. And of course, the longest side is still the hypotenuse. It always is, okay? The name of that side will not change, but the adjacent and the opposite can flick around depending on where that angle is, okay? So we'll do a bit of practice with that first. We'll talk about it again because it's worth really cementing in place. So, hypotenuse. It's the longest side opposite the right angle. Then on this side, give you a moment to guess. And of course, it should be the opposite side because it's the opposite the angle in question. So that's the angle that we're given. And that means that this last remaining side is the adjacent because it's next to the angle that we're given. Okay. So in this case, which is this side marked with an X? Okay. Now I'll just give you a few seconds on that one to make your decision. Of course, you can cheat and pause and work it out if you want, but that's up to yourselves. I don't mind if you do. Okay. And of course, the side marked with the X, it should be the opposite because it's opposite our given angle. Okay. So we're going to be dealing with the three main ratios. Okay. The sine ratio. Then we've got the cosine ratio and the tangent ratio. Okay. And it's all well and good writing them out like that, but I find it doesn't really help us because when we see SOHCAHTOA, we remember SOHCAHTOA, but it doesn't help us fantastically on that. So I'm just going to switch back to the camera. We should now have a clear view of that. And then we have our example there now, SOHCAHTOA, which we've just seen. So we've got sine, cosine, tangent. But I would always prefer to see them written as triangles, okay? Now, they don't have to be tidy triangles, as you can tell by mine. Mine are all different. And we've seen triangles like this before in different places. But one of the main places where we've seen them is to do with speed, distance, and time. Okay? And just like that, we can put our line across and a little multiply sign in the middle if we want, because we can do the same with our triangles here. And it helps us separate what we need. So if I put my line across on each of those, put a little multiply sign in, that's going to tell me exactly what I need for each step, okay? So we're going to talk, as we go through the questions, we'll talk about what we call the cover-up method, okay? And it depends on what we're after, okay? And in some cases, so we'll pick out the sine. We know if we cover up the sine, so we know the sine of my angle, so sine of theta, if I cover that up, it's equal to opposite over a hypotenuse, okay? If I needed to know my hypotenuse, I would cover up the h. And this time, I know that the h is now equal to the opposite side over the sine of my angle. And if I needed to know the opposite side, the opposite is now equal to the sine of my angle times by the hypotenuse, okay? So we're using that in the same way that we would the speed, distance, times triangles. We're just using the cover-up method to identify each one we need. So again, here we would have, so the cosine of my angle is equal to adjacent over hypotenuse. The hypotenuse is equal to, and this time it's the adjacent over the cosine. And the last one would be the adjacent, which is now equal to the cosine times by the hypotenuse. Okay, I'm just going to draw a little line between these so we can see where they don't cross over. We can see they are definitely separate. And the last one is the tangent. So the tangent of my angle, if I cut up the t, it's equal to opposite over adjacent. If I cover up the a, because I need to find the adjacent side, we've now got the opposite over the tangent. So that's opposite over the tangent of my angle. And the last one, if I need the opposite side, I would cover up the o, and I'm left with the tangent of my angle multiplied by the adjacent. Okay? And that's how the ratios break down. So as long as we remember to write SOHCAHTOA, we can identify the ratio, and we can then identify the formula that we need. Okay? So I'm going to put this to one side for the moment. We will come back to it. I'm just going to go back onto that PowerPoint. So everything's there, as we've seen already. So for sine, they do some lovely examples here. And this was a PowerPoint put together by colleagues from years ago, and we do find it useful. But I tend to find use it as a starting point and do these on the board anyway. So that's what I'm going to do with the pad this time. Okay. So in this case, we know that the sine of our angle is equal to the opposite over hypotenuse. Okay. And we're given the hypotenuse. And if we put sin 30 into our calculator, it should give us the same as 5 divided by 10. Now, again, this is why I prefer the pad. I'm going to go back to the pad now, okay? So now I've gone back to that pad. See what we've got on here. So this is my sine example, okay? And what we're looking at, okay? So we've got the sine of our angle, we've got the opposite, we've got the hypotenuse. So now what we're talking about is we're trying to find the opposite side. So this is my hypotenuse. This is the opposite side because it's opposite the included angle, and this one is the adjacent side, okay? Now, we're already given the hypotenuse, so we can now circle that. We know we've got that in place, and we're being asked to find the opposite, so we can circle that. We don't need the adjacent, and this helps us to figure out which one we're going to do. We'll talk about that a bit more in a couple of examples time, okay? Now, what it's telling us is the sine of my angle, so the sine of 30 degrees, I'm going to put that in brackets, is equal to, and we know from our triangle up here, the sine of my angle is equal to opposite over hypotenuse. So that's the opposite over hypotenuse. So if I then substitute in what I know, I don't know the opposite, but I do know the hypotenuse, okay? And that's 10. So we know the sine of my angle is equal to, and that's actually the letter O, not 0. So that's the letter O, and it's divided by 10. Okay. Now, in this case, what we can do, we can actually compare the values because we've got an equal sign in there. We know exactly what's going to come up. So if I on the calculator, and we can see the screen now, I'm going to press sine, then I press 30, I close the brackets. When I press equals, it gives me 1/2. So the sine of an angle of 30 degrees is equal to 1/2. So that means that whatever O is, when it's over 10, that must also now be equal to 1/2, shouldn't it? Okay. So if we'd have brought that down to 1/2, we know, well, how many 2's in 10? There's 5. So we know that that would be 5 as well, and that will give us our 5. Okay. Now, it's messy doing it that way. What we're better off doing is coming back to this idea that we did before. Let me draw a line under there. We've got our triangle. We need to find the opposite. And again, we look back from what we had before. It says, trying to find his right piece of paper. It's covered it up. Oh, there it is. That's exactly what I was looking for. And we're after the opposite now, aren't we? And we know the opposite is equal to the sine of our angle times by the hypotenuse. So we need O. O is equal to sin 30 times by the hypotenuse. Okay. So that is sin 30 times by, and our hypotenuse is 10. Okay. Let's type that in as it appears. So we've got sin 30, close brackets, and then times by 10, and we get 5, which is what we'd worked out before, and we know that's going to be good. Okay. And that's the easiest way of doing it in my book. Okay. If we use the cover-up method that we've talked about to find out each of the formulas in turn, we can just substitute what we need and we can work them that way. Okay. I reckon that's the best way to do it. So let's keep going on these. So that was my sine example. On to the cosine example. We can already see our different formulas there. So in this case, on our cosine example, we are looking to find, this time, we want to find the adjacent, okay? So we're after the adjacent side. We're already given the hypotenuse. And although we do know that this is the opposite, we don't need it, put a line through it. We're given our hypotenuse, we're asked to find the adjacent, okay? We've got the same again, haven't we? We need to find the adjacent. But this time, I'm going to cover up the A. So that is now equal to the cosine of my angle. The cosine of my angle, and I'm going to multiply it by the hypotenuse. So substitute it in what I know. I've got the cosine of 53 times by our hypotenuse, which is 9. Okay. So again, come back to our calculator. So cosine 53, close brackets, times by 9, and that's going to give us, and in this case, we're going to round it. I'm going to go 2 decimal places, so we've now got 5.41, sorry, 42, making my own mistakes there, and that's centimeters, and of course, 2 dp for that one. Okay, and that should see us right for the cosine, shouldn't it? Okay. Now, when you look at the PowerPoint, and it does go through, it starts off just as the previous one did. It starts off with the original formula, and then it rearranges it and this, that, and that. If we use the cover up, we can skip that first step and just go straight to the one we need. We're always left trying to save a little bit of time and effort on these questions, so we can do that. Okay, so that's sine and cosine. So let's do our tangent example. Okay, and for our tangent example, what we're after now, on this one, they're asking us to find the opposite side. Okay, so we know this is the included angle, so this is the opposite. We know this is the adjacent because it's next to the included angle, and this, as always, is our hypotenuse. But we're after this, and we're given this. We don't need that one. Okay, so I'll put a line through that. And again, we're after the opposite. So I'm going to cover up the O. We know that the opposite is equal to tangent of my angle, and this time it's multiplied by the adjacent. So the opposite is the tangent of the angle multiplied by the adjacent. So we will then have tan 33, and it's multiplied by, this time it's going to be multiplied by 11. Okay, so clear that one off. So we're now doing tan 33, close the brackets, times 11. Okay, and that will give us 7.14 to 2 decimal places again. Okay, so 7.14, and it was centimeters, wasn't it? Yes, centimeters, and again 2 dp. Okay, now they're just examples for what we're doing. We're going to start getting on to some of the main questions for now, but that just gives us a basis of what we're doing. Okay, now I'm going to switch back to the PowerPoint briefly. There's our tan example, which we've just seen and gone through. Okay, so we're here, and it says initially it says which ratio, and we're given a triangle, and it tells us a whole bunch of stuff about it. So we're given the included angle. We know it's a right angle triangle. We can now forget that 90 degrees. We need to label our sides. Okay, so what we need to do, oh, hang on, it skipped straight forward. That's really useful. We know, in fact, do you know what I'm going to do? It's going to be quicker and easier if I do it this way. Let's skip that. Go back to our triangle here. This is why I end up doing things on the board so much. They're quicker. Okay. There's our triangle. And I'm just going to put in Sokotoa. Written in triangles, but not necessarily showing the triangles. Okay. That will do for us. And when we look at the sides that we've got, let's do these in a different ink. We know the longest side is our hypotenuse. There's my included angle, so this one must be the opposite side. And that means that this one, next to the included angle, that must be my adjacent side. Okay. Now we're given the adjacent, so what we can do is I can circle the A on each of these. Okay. But there's no adjacent for sine. So that's gone. We get rid of that. And we're being asked to find the opposite. I've circled the A on that one. I never meant to do that one. Sorry. Let me start that again. Scrap that. See how easy it is. But how quick it is. Just write these out each time you do a question. So let's come back to this one. We have the adjacent. We look at sine, no adjacent. Cosine has adjacent, and tangent has adjacent. Okay, so we've listed all of those on there, like what I did up there. And we're asked to find the opposite. And as we look across, we've got the opposite here. We've got no opposite here, and we have the opposite here. Okay. So basically, we're looking at the two sides, and the only ratio that has both sides, the one that we have and the one that we need, is the tangent. So that means we can rule those two out. They're gone. And that means we're going to be using tangent. So we know the tan of our angle is equal to opposite over adjacent, and we can work from there. Okay. It's step one, and it's the most important step that we do. And you've seen just how easy it is to make that mistake as well. Okay. Let's pop back onto the PowerPoint. I've got a sneaking suspicion we're going to be skipping from it very soon. So for this one, we're going to calculate the length of the opposite side. And yeah, I'm going to split straight back from it, and we are going to work on the pad. Okay. Okay. And you'll notice I've done some notes on the side of this, and we're going to keep coming back to it. So in this case, it wants me to find x. So step one, let me bring that a bit more into focus. We're going to label the triangle. Then we're going to choose which rule. Then we're going to use the cover-up method to decide on the formula. Substitute the values that we know, and then the very last step is calculate. It's the last thing we need to do there, okay? So label a triangle. We know longest side, always hypotenuse, okay? This is our included angle, so that means that is our opposite, which means this one must be our adjacent, okay? Now I'm doing abbreviated words. You can just put H, O, and A for those ones. It doesn't matter. Okay, we'll get you to where you need to be. So now, back to this. When you do repeated questions of these, you will get fed up with writing SOHCAHTOA, but it's worth doing. Okay. And what we can do, again, let's look. We're given the hypotenuse. So we've got it there, and we have it there. But it doesn't appear in tangent. So get rid of that, it's gone. And we're asked to find x, which is the opposite side. So we're after O. Now, O appears there, but it doesn't appear there. So that's gone. So we've now got, we know we're using the sine rule, okay? So we've done step 1, labeled it. We've done step 2, we've chosen the rule. And now we use the cover up. And we need to find x, which is the opposite side. So we cover up the O. And now we've got the opposite is equal to the sine of my angle, and we're going to multiply that by the hypotenuse, okay? So that, we've now chosen the formula. Now substitute what we know. So we know that the opposite is equal to the sine of the angle, and we're going to multiply it by the hypotenuse, which is 10, okay? And now the last step, step 5, that's where we come in with the calculator. So all I'm going to do is sin 63, close brackets, and multiply it by the hypotenuse, which is 10. And I'm going to give it 1 decimal place this time. And we've got 8.9 centimeters. I'll just say 1 dp, covered in all my bases on there. So when you look at those, hopefully it's not quite as scary as they were in the first place. It will take some more practice, and we are going to do more practice with these, and I will send out extra work with them. But as always, those rules: label the triangle, choose the rule, use the cover up method, substitute, and then calculate every time. Okay. I'll just give it a pause for a moment. And what we're going to do is carry on. So you may notice on the corner of these, it says slide 14, the others just have numbers on them. And that's, if you are keeping up to date on what's on the PowerPoint, you can then, you know what we're referring to, okay? So now, slide 15, we're going to find y this time, okay? Now, 2 things, which is sharper than I amongst you will know, and those who like drawings to be perfect will have already been screaming about. I know that my triangles haven't got proper sharp corners on them, as they should have, because I've been cheating and using a set square to draw my triangles, okay? Life's too short to make them perfect. Do we trust drawings on an exam? No, we don't. So I'm not going to trust mine, okay? So we remember our steps from before. Step 1, label the triangle. Longest side, hypotenuse. That's our included angle, which means that is the opposite, which means this one must be the adjacent, okay? Now we're given the opposite and we're asked to find the hypotenuse, so that means the adjacent isn't relevant to us, okay? So I'm just going to put a line through that. I'm going to come back to SOHCAHTOA. Honestly, after teaching lessons on this all week, you can get fed up with saying SOHCAHTOA. So we're given the opposite, but we can see it there, and we can see it there, but it's not in cosine, so we get rid of it. And we need to find the hypotenuse, which is there, and it is there, but we've already got rid of it, and it's not there. So again, we know our formula straight away, okay? So we've labeled it, We've chosen the rules. So step 3, we do the cover up method. We're asked to find the hypotenuse. So this time we're going to cover up the h. So we know that the h is equal to the opposite over the sine of my angle. So now I can do step 4, which is substitute. So we know the hypotenuse is equal to, our opposite is 8. And this time it's over the sine of 49. Okay. And we just type that into the calculator exactly as it looks. Okay. Now we know we don't have to do h is equal to. So I can just press my fraction button, 8, move down, and then I can do sine 49, and again, close the brackets. The reason I always close the brackets is good practice to get into, because quite often, if we don't, it will upset the calculator. You'll get a syntax error. Okay, then we can press equals, and we've now got 10.6. Okay, and again, we'll round that to 1 decimal place. So we've now got 10.6 centimeters, 1 dp. Okay. And the last little thing that we can do on these as well, just for our own peace of mind, really, is we've worked it out as 10.6 centimeters, and that's more than the 8. So it is a longer side, isn't it? We know if this had worked out as less than one of the other sides, we know we'd have a mistake there. Okay. That's slide 15. So obviously, which follows, you would imagine, will be slide 16. And here it is. Get rid of that one as well, because we did that one ages ago. Another wonderful triangle. This time again, we're after the hypotenuse. We've got this side, but the angle's changed, hasn't it? So let's go through the motions. Step 1, label the triangle. Okay. We know this is the hypotenuse. The longest side opposite the right angle is our hypotenuse, and it's what we're being asked to find as well. Okay. This is our included angle. So that means that this side over here is the opposite now, because the angle has moved. And that means that this is next to it. So this is our adjacent next to. Okay. So we're given the adjacent. We're asked to find a hypotenuse. We've got no interest in the opposite. I'm going to put a line through that. So we've labeled the triangle. Now we look on pick our rule, choose our rule. So we're back to SOHCAHTOA. And we're given our adjacent. So I can circle adjacent there and adjacent there, and it doesn't appear in the sign. So we get rid of that, and we're asked to find the hypotenuse, which appears in cosine, but not in tangent. So that's gone. So we know we're using the cosine rule. And because we need to find the hypotenuse, we do the same as we've done before. Step 3, we do the cover up. So we cover up the h. And our h is now equal to the adjacent over the cosine of our angle. Adjacent over cosine of our angle. Okay. Step 4, substitution. Let's put in what we know. So the adjacent is 9, and our angle this time is 17. So we've now got cos 17. Okay. And again, last step, back to the calculator. And we're putting it in as fractional form. So we've now got 9 over cosine 17, close brackets. Okay. And we can see there that that is written exactly as it is there. So when we press equals, we know we're good with that. Okay. And we'll do 9.4. And again, it will be centimeters. And we're looking at 1 decimal place for that one. Okay. Happy with that so far? I'm hoping so. As I keep saying with these as well, if you want to be practicing these as you're going through, then what we can do is each time I come up with a new question on a new slide, we can just pause the video if you want while you try it yourself, and then follow the steps as we go through it. Okay. So that was slide 16. We'll do 17 now. So yes, again, it tells us here, find the adjacent side. It hasn't actually told us anything yet, has it? We need to know. It might say find A, it might say find the adjacent side, depends on what the question is. Okay. Now, first step, label the sides. Longest side, hypotenuse, opposite the right angle. Our included angle is back in this corner now. So we know that this is the opposite, which means that this is the adjacent because it's next to the angle. Okay. We're asked to find the adjacent. We're given the opposite. We're not given anything. We're not interested in a hypotenuse. I'm going to put a line through that. So step one is done, labeled. Okay. Now we're going to choose our rule. So back to SOHCAHTOA. We're given the opposite. So we can see we've got opposite with sine. We've got opposite with tan, but we haven't got it with cosine. Okay. And we're asked to find the adjacent. Adjacent doesn't appear here, but it does appear here. So that means we're dealing with tangent this time, okay? And again, we're asked to find the adjacent, so cover up the A. So our A equals opposite over tangent of my angle, okay? We're just getting a little bit of sunlight creeping in there. As the sun comes round, shouldn't really complain about the sun, should we? I'll just move the head over a little bit so we can see it a bit better. You can tell this isn't professional, can't you? So now, we've done step one, we've labelled. Step two, we've chosen the rule. Step three, we've used the cover up to decide which formula. So step four, we now substitute. So our opposite is 21 and our angle is 35. Well, that's it. That's what we're going to put into the calculator. Let's clear that. So now we've got 21. And then putting that over the tangent of our angle, which is 35, close the brackets. And we've now got, now if I'm going to round that properly, if I go to 1 decimal place again, well, I'm going to have to do 30.0 and centimeters, and again, 1 dp. Okay. Now again, I know we keep coming back to this with rounding, don't we? Okay. If I had, so I'll argue this one, we've got 29.9911 and some more numbers. Okay. If I go to 1 decimal place, I go there, the 9 rounds up, which means that goes up by 1. And because that goes up by 1, that goes up by 1 as well. Okay, as does that. And that's where it carries across. Okay, but because it's 1 decimal place, we still use that 30. Okay, could have just as easily rounded that to just the nearest whole number, couldn't we? Okay, but we can do it with that. Okay, so that's 17. I think we've got a couple more examples to go through, which of course you can be practicing at the same time. And then I'll give you some freedom to go back over some of the other questions. So, step 1, label hypotenuse. This is our included angle, so that's the opposite, which makes this the adjacent. Okay. I'm not going to cross any out these times because we don't have to. It doesn't make any difference. So again, in fact, I'm going to do this underneath now, just because the light's better underneath. So SOHCAHTOA. I often get asked, do I have to write that in the exam? It helps, honestly, it really does. You only need to write it once, and it helps prove to them you know what you're talking about. Okay. So in this case, we're still after the hypotenuse. Okay, we're trying to find the hypotenuse. So we've got hypotenuse there and there, but not in tangent. And we're given the opposite. I've got opposite there, but I haven't got it there. So we already know what it's going to be, don't we? Okay. So again, hypotenuse. We covered up the h. Hypotenuse is equal to opposite over the sine of my angle. Okay. Substitute. So the opposite is 10 and the angle is 17. And then the last step is calculate, and we just type that in exactly as it looks. So in this case, we've got 10 over sin 17, close brackets, and that's going to give us 34.2 centimeters. And again, we've gone on this one, we've gone 1 decimal place. Okay. Now I know I keep rounding and showing you what we're rounding it to and things like that. If they have asked you to round it, it's an extra bonus mark. If they haven't, and pretty much if you've got 34 point something, you will get the marks for it, okay, if they haven't been specific about that, okay? So don't get too caught up with it. Be careful, but it isn't the be-all and end-all, okay? So we've done lots of practice about finding the side. And for the last two examples, we're going to change it up a little bit, okay? And in this case, what it's asking is to find the angle x. Basically, that's what we're after, okay? And again, for those of you who like drawings to be perfect, you will notice that it's definitely not to scale, is it? 12 and 7. But it will do for us, okay? The steps remain the same, okay? It's the very last thing that we do that changes. That's all when it comes to finding an angle. So step 1, label your sides. Next one, our longest, is always our hypotenuse. That's our included angle, which means this is our opposite. And that means the one next to it is our adjacent, okay? So we come back to our rules. We go SOHCAHTOA. And in this case, again, basically, because we're asked to find the angle, we're given the two sides. So we mark down which sides we have. So first off, we're given the opposite, which is here and here. So it's not cosine. And we're given the adjacent, which is here, but not here. So it's not that. So now what we know is, and the trouble is we're after the angle, aren't we? So we're covering up the t this time. The tangent of my angle is equal to opposite over adjacent, okay? We can substitute that. So we know that the tan of the angle is equal to, and the opposite is 7, and the adjacent is 12. So gives us an idea of what it will be equal to. But now this is where we step in with the calculator, and we only change one thing, okay? And what we do is we are after now the inverse of sin, cos, and tan. Now, if I zoom in a little bit, hopefully we can still see that on there. Oh, that's bad for the eyes. Let me try and focus in. Here we go. You can see those just about there now. See, just above each button, we've got sin to a -1, we've got cosine to a -1, and tangent to a -1, okay? That's what we call the inverse function, and that's what we use to work out the missing angles, okay? Sorry if you get motion sickness. I'm just trying to move the camera to a better position. I have to refocus again. Okay, so what we're actually going to do is we need to do tan to the -1, so the inverse tan. When we do that, move that over so you can see the screen. So I'm going to press Shift and then the tan button, and we get the tan to a -1, but then I want you to press the fraction button, because we're then going to put in our opposite over adjacent. So we're then going to put 7 over 12, move that to the right, so it's now to the correct side, and close your bracket again, okay? So we've now got tan to a -1, 7 over 12, okay? When we press equals, that should give us, and I really am going to round that to the nearest degree. We now got 30 degrees, okay? And that's how we do it, okay? We did all those steps the same. We labeled, we chose the rule, we covered up to get the right formula, and we substituted. The only thing we did different, because we needed to find the angle, we used the inverse function then. That was the only difference, okay? So we do one more of those, and I'm going to let you loose on the other questions. Okay. So back to our start point. This time, find the angle x, and we've got different sides. So longest side, hypotenuse. This is our included angle, which means this is the opposite, and that means that this must be the adjacent. Okay. So now we need to choose which rule we're going to use. So back to SOHCAHTOA. And we're given the hypotenuse. So I can circle sine and cosine, but I can cross out tangent because it doesn't occur. And here we've got the opposite, which comes here, but doesn't come in cosine. So we've ruled these two out. So we know the sine of my angle is equal to opposite over hypotenuse. Okay, we've seen that in place already. So now we can substitute. Sine of my angle is now equal to, now the opposite is 9, and the hypotenuse is 14. And this time we want the inverse. So we do the sine to the -1, and then we're going to put that in the bracket after it, 9 over 14. Okay. So again, clear that one from our last one. So shift, and we move that over so you can see that screen better. So shift, and that little s comes up in the corner. We press sine, so we've got sine -1, and we press our fraction button to bring that up, and then we can just type in 9 over 14. Don't forget, move to the right and close your bracket as well. You don't want to upset the calculator because you'll end up retyping it. Okay, press equals, and in this case, we should have 40 degrees. Okay, and of course, that's just rounded to the nearest degree. Okay, so hopefully that helps. The main things we need to remember, it comes back to this each time, doesn't it? Okay, so our rules. Number 1, label the sides. Okay, so label the sides of the triangle. Number 2, choose the rule. Okay, sine, cosine, or tangent. Okay. Number 3, cover up. Sorry, it's covered up there. Choose formula. And that's when we cover up. Okay. So in this case, if we wanted the adjacent, we cover up the A, and we'd go with those. 4, substitute. And that's when we transfer, we replace the O and the A, or whichever we're using, with the values we've got. And then that's step 5. The last one is calculate. Okay. So we only actually need the calculators for that very last step. We can prove how clever we are all the way up to there. And even if we do get that wrong, just means we're going to miss out on the final answer mark for it. Okay. All right. So on the email, you should have been, when you were shared the link for this, you should have also been shared some worksheets. So have a go at those. Let's see how you get on. And any problems, have a word with your tutor. Okay. And don't forget, you can always rewatch the video if there's something you're not too sure of. Brilliant. See you soon.